Okay, this is Algebra 1. Today we're looking at section 1.2, exponents and powers. A couple of goals we have on page 9. Evaluating expressions containing exponents and then using them in real life problems. First thing we have is a handful of definitions. First one says power, the result of a repeated multiplication. The entire thing, everybody, is the power. The entire thing, like x to the third power. That's x to the third exponent. People read it as to the third power. This is the entire thing. Or 2, this is an easier one for you to look at this point, 2 to the third power. One of them is the base and one of them is the exponent, but the entire thing together is the power. The base is the number or variable used as a factor in repeated multiplication. So if we use that same one, 2 to the third, the base is this part right here. It's the number you're actually going to multiply times itself, the amount of times that's given to you in the exponent itself. The exponent is the amount of times you're going to multiply it. It's the number or variable that represents the number of times the base is used as a factor. Again, same example, 2 to the third power. The exponent is the third power. It's the one that tells you how many times to multiply it. And in grouping symbols, a lot of times we'll talk tomorrow or the following day about our order of operations. A lot of people just assume that grouping symbols is the P in please excuse my dear Aunt Sally. And if you never heard that expression before, you'll understand what I mean in a couple of days. But the P is just parentheses. It's actually all grouping symbols, including parentheses, brackets. That's another one that most people are familiar with. Braces, this is another one that some people are familiar with. Looks something like that. Braces, and then there are some other grouping symbols, special grouping symbols we'll talk about. But it just creates the order that you do the innermost ones inside of grouping symbols first. Here's example number 1: reading and writing powers. It says express the meaning of the power in words and then with numbers. So the first one says 15 and then as an exponent of 1. So you read that just like that. 15 to the first power. If you don't have that written down, copy it down now. 15 to the first power. The meaning means 15 times itself only one time, so the meaning is simply 15. B is 5 raised to the second power. You can say anytime you have something raised to the second power or to the third power, which we'll look at and see in a second, there's another way to say it. 5 to the second power is the same thing as 5. Notice it's written 2 different ways, as 5 squared. A lot of people would prefer to say that it's 5 squared because it's faster to write that 5 squared. It's faster to read it too. But it's not wrong to say it's to the second power because that's what it is. And its meaning means 5 times itself, 1 time, 2 times. That's why it says 5 times 5. And then C says 6 raised to the third power. Again, you could read it as 6 to the third power, which is 6 times 6 times 6. That's 1, 2, 3 times. The other way to read it again is 6 cubed. So you can say squared anytime something is to the second power as squared. Anytime something is to the third power, you can say it as cubed. Copy this next example down real quick. You don't have to write all of the words on top of it. Just do A through E real quick. I'll give you about 1 minute to write what it means. You don't have to multiply out 9 times itself 7 times. Just write the meaning of it. Take 1 minute. Do those 5 real quick. Okay, let's take a look at these. The first one, it says express it in words and then in numbers what it means. So this first one, 8 raised to the first power means 8 to the first power. And that means 8 times, I can't write the last letter for some reason, 8 times itself one time. That's what it means. The next one is 6 to the second power. Remember, has the second power, which means squared, so you can write it a little quicker. 6 squared, which means 6 times 6. The next one is 4 to the third power. Again, that's 3, so you can write it a little bit quicker and say 4 cubed, which means 4 times itself 3 times. 9 to the seventh power. There's no shortcut way. There might be some really long shortcut way, which don't make it a shortcut at all, that a bunch of scientific people understand. But the rest of us simply write this as 9 to the seventh power, which means 9 times itself, and just count. 1, 2, 3, 4, 5, 6, 7. Then this last one is the only one that is unfamiliar to most of you guys, or some of y'all. Some of y'all might kind of understand what's going on. It says y to the nth power. So you read it like that. I know that sounds funny to say that, but y to the, and here's another word right here, nth, nth power. And all that represents, it's another variable. We talked about variables in the last lesson. It's just a variable power that you're going to raise it to. The nth power means y times itself however many times that n says. We don't know how many it's going to be, because you can represent y times itself as many times as you want by plugging in a different number or a different value in place of n. So just read that. Most importantly from that is to get you to understand how to read that to the nth power. Example number 2 says evaluate the expression x to the fifth power when x equals 2. Here we go. Now we're evaluating, which means we're going to substitute something in first, and then we're going to go ahead and multiply it by itself as many times as the power says to. So x to the fifth power, when x is 2, you substitute in place of x, you plug in a 2, which means, and then if you look off to the right, it says substitute 2 for x. And this is what I was explaining to you guys earlier. The blanks on the right might seem a little bit confusing to you, but once you fill them in on the left, usually you can figure out what they're asking you for on the right. That means 2 times itself 5 times. 1, 2, 3, 4, 5. That's how many there are. Then multiplying each of those by each other, we're going to get to the number 32. So that's example number 2. 2 times itself 5 times is 32. Okay. Evaluate this next one again. You can do it on the back or on the margin. There should be plenty enough room. X to the fourth when x is 3. You don't even have to write this part of it, or just write this part. X to the fourth when x is 3. Take about 30 seconds to do that one. Okay, let's take a look at this one. It says x to the fourth when x is 3. Whereas first thing we're going to do when we're evaluating this is substitute that number 3 in place of x. So what that creates is 3 times, I'm sorry, if we write it out each step, it's going to say 3 to the fourth power, which means 1, 2, 3, 4. Okay? So the easiest way to do this, you could just multiply them straight across, or you can do it this way. Like I showed you, 3 times 3 is 9. 3 times 3 is 9, and we know that 9 times 9 is 81 for that one. Okay. Example number 3 is evaluating an exponential expression. Evaluate a minus b to the fourth when a is 5 and b is 3. So you're doing it just like the last one, except you're substituting the values in 2 different spots. You're substituting one of them in for a, 5, and you're substituting one of them in for b, 3. Notice the minus doesn't change. You're just leaving a minus in place. You're just plugging in or substituting in 5 for a, 3 for b. So once you do that, do what's inside parentheses first. 5 minus 3 is 2. So now you're left with 2 to the fourth power, which means 2 times itself 4 times, writing out the factors. 1, 2, 3, 4 times. And when you multiply 2 times 2 times 2 times 2, we figured this out earlier, we get the number 16. Okay, let's take a look at our extra example from that one. A is 3, B is 4. Notice the numbers aren't changing from A and B, problems A and B. Take about 35 seconds to do that one. Okay, notice these problems are very, very similar. When you read them out loud, they'll sound exactly the same. A is 3, B is 4. A plus B cubed, A plus B cubed. Notice it sounds exactly the same when I read A and I read B. The parentheses is what's going to make the difference. In place of A, we're going to plug in 3. Plus, in place of B, we're going to plug in 4. Notice it's in parentheses first. And again, we'll talk more about order of operations in our next lesson. But 3 plus 4, you do it's inside parentheses first. 3 plus 4 is going to give us 7. It's 7 to the third power, which means 7 times 7 times 7. We know that 7 times 7 is 49. Now we got something we can't do as easy. You might have to stack them on top of each other. 49 times 7. 7 and 9 when you multiply them is 63. 4 times 7 when you multiply them is 28. So that's going to give us 343 for that one, 343. Okay. For A plus B to the third power, notice again, as we read it, it sounds exactly the same. But when we plug it in, it's going to act a little bit different. A is going to be 3 plus B to the third power means B to the, I wrote in the wrong number. Make sure you don't do what I just did. B is 4 to the third power. That's in parentheses. So before we add 3 and 4, now we're going to do 4 to the third power, which means just like this, 3 plus, and then it's 4 times itself 3 times. 4 times 4, we found out earlier, was 16, times 4 is going to be 64. So 3 plus, and then we have, putting those three together, is 64, which is going to give you 67. Are there any questions on those? Okay, let's take a look at example number 4, evaluating an exponential expression, a squared plus b squared when a is 7 and b is to the 4th power. Notice this is just like the second example from a second ago, or b from a second ago. A squared and b squared, a is going to be 7, so 7 squared plus b is going to be 4. 4 squared, all you're doing for the first step is substituting in 7 and 4 for a and b respectively. Once you do that, 7 squared is 49. 4 squared is 16, evaluating the powers. Notice we didn't write out that middle step here where we're doing 7 times 7 and 4 times 4. We're just going right to evaluating the powers, and then adding them up is going to give you the number 65. Okay. Take about 30 seconds and do this extra example. Okay, we went a little bit over, but first one, 3x squared. The second one, 3x squared. Notice when you read them, they sound exactly the same. That parentheses is what breaks up what's going on. It tells you x is 5. So in place of this one, we're plugging in 3 times 5 squared. Anytime you plug something in, it acts like it's in parentheses. If you didn't write the parentheses, it's not going to make a difference in this case. When we start getting where we have negative values, you'll see where the parentheses might mess it up or not. I'll show you those when we get to them. But this says 3 times 5 squared. Again, when we get to order of operations, this will be easier to decipher. But you do the exponent part first. So you do 3 and then 5 times itself 2 times, which means 5 times 5. So 3 times the number 25, and we know 3 times a quarter is 75 cents. So you get the number 75. B says 3x squared. Again, you're plugging in that same value, 5, in place of x. So 3 times it acts like it's in parentheses. I'm not going to write it right here just so we don't have to put brackets, squared. The difference between this one and the other one is that now you got to do what's inside parentheses first. 3 times 5 is 15, and that's going to be squared, which means 15 times 15, which is 225. 15 times 15 is, in fact, 225. The more you work with these numbers, the faster you are at multiplying them. Again, we'll practice more multiplication. Let's look down to our checkpoint example. Notice this says 3 to the nth power plus n to the third power. So all I did was transpose those two numbers for you. So what that means is 3, it tells us the value of n is 5. So to the fifth power plus, again, the value of n is 5 to the third power. So 3 to the fifth power means 3 times itself, 5 times 2, 3, 4, 5, plus 5 times itself, 3 times 5 times 5 times 5. You might have to do a little bit of work out on the side to get this one done. But 3 times 3 is 9. 3 times 3 is 9. Times one more 3. 9 times 3 is 81. And we did this one earlier. 81 times 3. 3 times 1 is 3. 3 times 8 is 243. So we got 243 from all of those numbers. When we do the same thing with our 5s, 5 times 5 is 25 times 5 more. Well, we know 5 quarters times 5 is $1.25 or 125. So when you add those two together, 243 plus 125 is going to be 368. 368. 2. Okay, for some reason, everybody, there was a mistake on this, just pointed out to me. For some reason, the copies, sometimes every now and then when I shrink them down, like a plus will turn into a minus, or a division sign will be kind of hard to decipher. It's just a copy mistake. Just go ahead and if you did it the other way, just copy this one down. You might have to move over to the back. But instead of saying 3 to the nth, it looks like minus n to the third on your paper. Just change that minus to plus, and then you'll have what I have. Otherwise, the only difference in what you did versus what I did up here is at that very end, instead of getting 368, you would have subtracted at this point right here, and you'd have got something just slightly different. You'd have got 243 if you just want to check your answer. Minus 125, you're going to get 100, and you should have got 118. But just make that change to get 368. Everything else should have been exactly the same. For the other one, let me make sure I got the other one written right. 3c to the fourth minus 18 to the c power. It looks like that's correct. C's value in this case is 2, so 3 times 2 to the fourth power minus 18, and all of this is inside of this set of grouping symbols. That c power is going to be squared. So we just got to work from inside out. Again, we'll talk more about order of operations in the next lesson. But 2 to the fourth power means 2 times 2, which is 4, times 2 is 8, times 2 is 16. So when we evaluate this part right here, 2 to the fourth power is 16 minus 18. That's going to be multiplied by 3, and that's going to be squared. You do what's inside parentheses first. 16 minus 18, if you think of it this way, if you are at 16 here and you subtract 18, you're going to go 16, 17, 18. So if you need to do that, by all means do that. But it's going to be negative 2. It's still in parentheses. You still treat it as if it's in parentheses, which means negative 2 squared, which means negative 2 times negative 2 when you evaluate that exponent. Negative 2 times negative 2 is a positive 4, and when you multiply that times that 3 that's still on the outside, you're going to get not 900, because I made a mistake somewhere. Should have gotten 12. Let me go back and check and see what mistake I made. Okay, I see the mistake I made from the very beginning, everybody. Let me correct all this stuff. We have to do the kind of what we did already. And we're going to have just enough time to finish up before we run out of time. But I tried to, when I added in the brackets is where I made my mistake. 3 times c, I'm not going to add in anything extra. 3 times 2 to the fourth power minus 18 squared. Okay, so now we're looking at something like this. Again, you still do 2 times 2 times 2 times 2, which is going to be 16 times 3. Notice that's inside that parentheses. That's the mistake I made. 3 times 16, we know 16, that's going to be 48 minus 18, and it's going to be squared. 48 minus 18 is 30 squared, which means 30 times 30, which does in fact give you the number 900.